All right, we're going to take a look at distinguishing between mutually exclusive and independent events. To start off with, we have a compound event is an event that is made up of two or more simple events. Events that have at least one outcome in common are inclusive, whereas disjoint events are events that have no outcomes in common. So inclusive have things in common, at least one, and then disjoint, there's nothing in common about them. So if we take a look at this spinning wheel, we can see half of them are blue, half are white, and they are numbered accordingly so that all of our possible outcomes are laid out for us here. We want to determine whether the compound event described is disjoint or inclusive. So the spinner landing on a blue sector, and then so that's important, and the spinner landing on a 4. So it has to land on both a blue and a 4. But if you look at the blue, there aren't any 4s there, so this one would be a disjoint event. Now that second one, the spinner landing on a blue sector and the spinner landing on a 3. For this one, we have this little slice of the pie right there that is both blue and the number 3. So this would be inclusive because those share at least one thing in common. Moving on. For inclusive events, if we are going to take the probability of an inclusive events or inclusive events A and B, we will look at the probability of A or B happening would be equal to the probability of A plus the probability of B, and then we would subtract the probability of them both happening. So since events that are mutually exclusive or disjoint have no outcomes in common, that last piece, the probability of A and B, is equal to 0. So for each of these, this would be equal to 0. They just substitute that in. So for mutually exclusive events, that formula would just be the probability of A plus the probability of B, like they have right here. So looking for the probability of A or B for mutually exclusive, or we could call this disjoint as well. That's just the probability of A plus the probability of B. All right. The jar contains 10 marbles, 5 red, 4 blue, and 1 green. The red marbles are numbered 1 through 5, the blue marbles are numbered 6 through 9, and the green marble is numbered 10. A single marble is drawn from the jar. Find the probability that the marble is blue or has an even number. So we're going to take a look at the probability that it's blue. So probability of it being blue or even. We know that there are 4 out of 10 blue plus even 2, 4, 6, 8, 10 plus 5 out of 10. Now minus the chance that we have a blue even marble. So blue are numbered 6 through 9. So we'd have a blue 6 and a blue 8. So that would be minus 2 tenths at the end for the probability of both blue and even happening. So this would be 9 tenths minus 2 tenths. We would get 7 tenths. Let's take a look. Same scenario, find the probability that a marble is red or has a 2-digit number. So in this case, that last one was inclusive because we had some things in common. We had some blue marbles that were even. In this problem, these are going to be mutually exclusive or disjoint because we have red marbles. We know that there's 5 out of 10 but none of our red marbles are going to be a 2-digit number. The only 2-digit number is that 10, which goes with green. So the probability of red, or I'm just going to put 10 because that's the only one, would be equal to 5/10 plus 1/10. So that equals 6/10, which simplifies to 3/5. Okay. All right, next, taking a look at dependent and independent events. So this is a topic that generally we should have some practice with. So here we have a jar contains 9 white marbles and 7 green marbles. Determine whether the listed are dependent or independent. Our first scenario here, a white marble is selected and replaced. Okay, this piece right here is crucial. Then a green marble is selected. Because this marble was replaced, this would be independent because that doesn't change the probability at all for the next scenario. If we pick something out and put it back, our probabilities would stay consistent with our 9 white marbles and 7 green marbles along with the total amount. Here, our next scenario, a white marble is selected, then without replacement, another white marble is selected. So this one here would be dependent. And if you want me to go a little bit further, we would have a probability of 9/16 of pulling that first white marble out. Then we keep it out, so if we take another one out, that second one would have a probability of 8/15 because not only did we lose one of our total, but we lost one of our white marbles as well. So if you notice, the probability from our first draw to our second changed. So the probability of 2 independent events, A and B, you would just simply multiply those two probabilities for an n amount of events. As long as they are independent, you can just simply multiply those all together. Like here. Great. So here we have 2 fair coins are flipped 3 times. Find the probability that both coins come up heads or come up 1 heads and 1 tails all 3 times. So because if I flip 2 coins, those are going to be independent events. One coin isn't going to affect the fact that the other one would get something else. So it's either going to be heads or tails. So the probability, let's say this is our situation 1, or our first event. I'll call it event 1. Probability of getting 1 heads and 1 tails is going to be 1/2. Probability of that happening again, still have 1/2. And that happens a 3rd time, still 1/2. So we have, remember we would multiply those probabilities together. So we would have 1/2 to the 3rd power, which would be equal 1/8. This would be our probability of those coins being flipped 1 heads, 1 tails in a matter of 3 times. Okay. The survival rate of giant panda cubs born in captivity is 59.4%. Find the probability that out of 4 giant panda cubs born consecutively into captivity, the first 2 will survive, while the last 2 will not. Round to the nearest 1,000th. Okay, so the survival of 1 cub isn't going to affect the survival of the next, so these as well would be independent. So the probability of them surviving, let me switch to a pen. If it was consecutively, this would be 0.594 times 0.594, and then this would be multiplied by the probability of them not surviving. And forgot I made this 0.406 times 0.406, and then I'm just going to multiply those together, and that will be our overall probability rounded to the nearest thousandth. So that'll be, we get 0.05816. So rounded to the nearest thousandth, that would be 0.058. Or no, they wanted 10,000th. That's my bad. So that'll be a 2, roughly. So that's the probability of that happening consecutively, where the first two make it, and unfortunately the second two do not. Okay, and that's all I have for today. I hope you guys gain something out of this. Hope you guys have a better understanding of both probability, disjoint events, and everything like that.